All right, now we're recording for Intensive Math Review, Section 3.2, Evaluating Algebraic Expressions. Section 3.2, Algebraic Expressions. And this begins on page 179. So you'll want to get yourself to page 179. So in example 1, they have this crazy expression, x to the second power minus 2xy plus y squared, and they say x equals -3 and y equals 2. So when you see that you have to evaluate an expression when they give you the value of x and y, what they're wanting you to do is substitute that value in for each one of the x's and substitute the y value in for each one of the y's. So you're rewriting your expression. I just made a crazy mess on my board, so I'm going to rewrite. Instead of x squared, I'm going to write, now this is careful, watch this, open paren, -3, close paren squared, because it's the entire x, -3. We don't want to write it without the parens or we get a mess, right? Remember that from our discussion about exponents and negative numbers. Then we have minus 2, open paren, -3, close paren, open paren, 2. So instead of writing 2xy, now we write 2, and then we substitute in -3 for x and 2 for y. And then we write plus, and then the y squared. Notice I'm going to do open paren, 2 close paren squared, just in case. Just get in the practice of writing those parens so you don't get yourself in trouble with the exponents. Now this is an order of operations problem, which you've been doing since chapter 1. There are parentheses, but there are no grouping symbols, so grouping symbols doesn't need to happen here. We need to do our exponents first. So -3 squared would be +9, 2 squared would be 4. Pull down the plus, the minus, the 2 times -3 times 2. All right, so you have 9 minus 2, open paren, -3, close paren, open paren, 2, close paren, plus 4. Then you do the multiplication. 2 times -3 is -6. -6 times 2 is -12. Notice I keep it in the parens because now I got to pull down the 9 and the minus and the plus and the 4, and you should notice you have a no negative, plus plus. Now you have 9 plus 12 plus 4, which is 25. In your book, it goes through each one of those processes for you to look at also, okay? So when you have to evaluate an expression given certain values, like x equals -3 and y equals 2, you substitute those values in for the x's and the y's, and then use your order of operations to solve the problem. Turn to page 180. Let's do another one. We have open paren, the very top of page 180, example 2, open paren, a minus b, close paren to the second power at a equals 3 and b equals -5. So we're going to substitute in the 3 for the a, so open paren 3, minus, substitute in the -5 for the b, so notice I put it in parens, minus a -5, because the minus stays there, and then we put the squared. You should notice right away that a negative is a positive, so 3 plus 5 in the parens is 8, and then 8 squared is 64. If you follow along that example in the book, they go through the same process. All right, next example, example 3 on page 180. They have the absolute value of a minus the absolute value of b at a equals 5 and b equals -7. So again, plug in the values for your variables and solve the expression. So we have a 5 for our a, so the absolute value of 5 minus the absolute value of -7. So then answer the absolute value. That's like a grouping symbol or an exponent. We want to answer it. What is the absolute value of 5? 5. What is the absolute value of negative 7? 7. So we have 5 minus 7, which is actually negative 2, isn't it? It's a positive 5 and a negative 7, so we get a negative 2 for our final answer. If you follow along in the book, that's what you should see for your answer there. Hold on one second while I grab this video to my last video to upload, and I can upload it on YouTube while I'm talking to you now. Okay. Multitasking. All right. Example 4 at the bottom of page 180 has evaluate the absolute value of the quantity A minus B. So absolute value open, A minus B, absolute value close, where A is 5 and B is negative 7 again. So we put absolute value open, 5 minus, open paren, negative 7, close paren, absolute value. Notice I substituted in the 5 for my A. I substituted in the negative 7 for my B. I needed to keep the minus in between, so we use that paren to show that. And then you notice it's a no negative, so that becomes a plus. 5 plus 7 is 12. The absolute value of 12 is 12. All right? So if you follow that example through on page 180 to 181, you'll see that they got to 12. Then take a look at example 5 on page 181. It says evaluate AD minus BC all over A plus B. And we've got a whole bunch of variables going on here. We've got A equals 5, B equals negative 3, C equals 2, and D equals negative 4. They're identifying your variables in this case. So you're going to plug in, you're going to substitute in each value of the corresponding variable. So the A is going to get a 5. So everywhere there's an A is going to be a 5. So we have 5 times, I'm using a paren to show times, negative 4, because that's our D, so that would be AD, minus, I'm going to put it in parens to be careful, negative 3, close paren, open paren 2, close paren. Notice how I'm showing the multiplication of BC all over A plus B, so that would be 5 plus a negative 3. All right, so you're going to simplify the top and the bottom. On the bottom, that's pretty basic. 5 plus negative 3 is a 2. On the top, we need to do the multiplication of 5 times negative 4, which is negative 20. And negative 3 times 2 is negative 6. And notice we have a 20 minus a negative 6, which means negative 20. Excuse me, I think I said 20. I need to say negative 20 minus a negative 6 would be negative 20 plus 6. Negative 20 plus 6 is actually 14, negative 14. And negative 14 divided by 2 is negative 7. If you walk yourself through the example on page 181, it does the same thing that I just did with you now. All right, turn to page 182. Page 182, and there is a picture of a rectangular prism. A rectangular prism has a rectangular bases and then sides, and we are going to find the volume, and they give you the formula that the volume of a rectangular prism is V equals LWH. What that means is length times width times height. It's the area of the base times the height. So the area of the base is a rectangle, length times width, and we times it by our height. And they're going to give you the measurements in the story problem. It says the volume of a rectangular prism given by the formula V equals LWH, where L is the length, W is the width, and H is the height of the regular prism. Find the volume of a rectangular prism having length, so L equals 12, width, W equals 4, and height, H equals 6. So we're just going to plug in these plug in these values into our formula. So volume equals 12 times 4 times 6. So you're going to do 12 times 4 is 48. 48 times 6 is 288. And it's feet to the third power because we multiply feet times feet times feet. It's three-dimensional when you label it. It walks you through that example on page 182. So that's section 3.2 on algebraic expressions and evaluating them by plugging in the values of their variables. Basically, it's just being really good and conscientious about copying down your problem, plugging in the correct value for your variables, and then using your order of operations very carefully. All right, so you should get through those exercises on page 183 to 186. The next video will cover section 3.3. See you in the next video.